Welcome back, students. We're going to continue our discussion of climate change. And in this video lesson, we'll get into what is called the greenhouse effect and explain what that's all about. But quickly to recap, we began by talking about Dr. Charles Keeling and how he began to measure the atmospheric levels of carbon dioxide as a research project. And he and others continue to do that since 1958 on, leading to a very rich set of data showing that there's an increase in carbon dioxide levels. And in fact, there's been at least a 25% increase since he began making his measurements. Then in the second video lesson, we talked about how scientists are able to go back in time by taking ice core measurements, drilling deep into the Antarctic, pulling out a cylinder of ice, and then measuring the content of the fossil air, the gas bubbles, trapped within that ice to determine the amount of CO2 over a period of time. And also scientists have a way of estimating the global temperature extending back in time. And we talked about some of those plots and how they reveal warming periods and extended cold ice age periods, and how Homo sapiens have probably survived through the last two ice ages. So that's a quick summary of what we've talked about. In this video lesson, we'll focus a little bit more on this plot that I've shown in each of the lead slides, what is sometimes called the hockey stick plot, which shows the correlation between the atmospheric carbon dioxide levels, that's in the red, and the average global temperature, that's shown in the blue. And as you can see, things kind of bounced around at certain levels until the last 50 years or so, in which things are shooting up. That, of course, is a concern. But to give you some historical references again, this goes back over the last 1,000 years. So over to the left, that would begin when maybe Leif Erikson was sailing from Northern Europe to Canada. And then maybe 1100 to 1200 is the Crusades. 1492, Columbus sailed the ocean blue. 1776, the Declaration of Independence. 1860s, Civil War. So that gives you some references that the temperature was fairly constant. There were some periods where it's a little bit cooler. Remember, we talked about the little ice age. But for the most part, the temperature remained fairly constant over these extended periods of time. Now, this slide shows a lot of data. So first of all, Tom, it actually is a different way to represent some of the data I've shown you before. That is, the top two panels show the atmospheric carbon dioxide levels. To the left is the historical data from the ice core going back to 400,000 years ago. And to the right, the last 500 years are expanded. And likewise, the bottom plots show the average global temperature extending back to 400,000 years ago. And then to the right, the last 500 years is sort of expanded and blown up so that you can see the correlations between the carbon dioxide levels and the average global temperature. The reason I wanted to show you this is to point out if you look at both the carbon dioxide plots, that is the top two plots, and the global temperature plots, the bottom two plots, only the data to the very right is actual experimental observations. That is, to the upper right are the measurements of Dr. Charles Keeling and others of actual atmospheric carbon dioxide levels. And to the bottom right, the global temperatures, are actual temperature measurements. So the measurements and the data that we extend back in time are reconstructed plots of carbon dioxide level and temperature. But again, these are reconstructions from ice core analysis to enable scientists to extend back in time estimates of both temperature and carbon dioxide levels. Let's now just look at the last 140 years or so. That is recent time, where we have consistent measurements of the average global temperature. And these are data collected by the National Oceanic and Atmospheric Administration, NOAA. And what NOAA does, among other things, is to have about 1,000 sites around the world where these may be in research stations, they may be on buoys, they may be on boats, where temperature measurements are made routinely of both the ocean waters and the land. And so what is plotted here is the average annual mean temperature averaging over all of these locations scattered throughout the globe to come up with an annual global mean temperature. And what you can see is the plot, and the most obvious thing is that has been an increase in the average global temperature, especially in recent years. In fact, 15 of the warmest 16 years have come since the year 2000. 2015 was the warmest year ever recorded, and very likely anytime I update this video lesson, I'll be able to say the most recent year was the warmest year ever recorded. In this graph, just to give you some idea of what is actually being plotted, it is a temperature deviation from an average between 1950 and 1970. That is, if you look at this plot between 1950 and 1970, the temperature didn't change a whole lot. It was kind of stable. I was born in 1951, so maybe there was a cooling effect due to that. But prior to that, as you can see, the temperatures were a little cooler, and that after 1970, the average global temperature has increased in a pretty steep manner. So anytime you see such plots where you see a temperature anomaly, it is comparing the average temperature of that year with that period of between about 1950 and 1970. So this says that in the most recent year, 2015, the average global temperature was about 0.87 degrees centigrade above the 1950 to 1970 average. Now that corresponds to about 1.6 degrees Fahrenheit, to convert it to a temperature scale that you're probably more familiar with. That is, the Earth is getting warmer. Now, it may not seem like a lot yet, but as we will talk about later, climatologists worry about the challenges that will arise if, in fact, the temperature continues to increase. We will talk later on about a 2-degree temperature change and how it's critical to try to maintain the temperature anomaly to be at or less than 2 degrees above that 1950 to 1970 average. Now let's get to the greenhouse effect, which is a hypothesis for what is causing this global warming. Sunlight from the sun impinges upon Earth, and this sunlight, this radiation, is mostly visible radiation, some ultraviolet, and about half of this radiation is reflected immediately back into space. The rest, or most of the rest, is re-radiated as longer wavelength, lower energy, infrared radiation. But here comes the problem. Greenhouse gases in the atmosphere can absorb this infrared radiation. Now this gets into chemistry. Certain molecules can absorb infrared radiation, others do not. Oxygen and nitrogen are transparent to infrared radiation, but other gases that I'll mention in a second will absorb infrared radiation. Now when these gas molecules absorb infrared radiation, as a consequence of the first law of thermodynamics, the energy has to go somewhere. That energy is converted to kinetic energy. Kinetic energy associated with the motion, vibration of these gas molecules, and that actually is what we call temperature. Temperature is a measure of kinetic energy, the motion of molecules. These greenhouse gases include, in order of capacity or importance, carbon dioxide, methane, halocarbons, nitrous oxide, ozone, and water vapor. To help you understand a little bit more about the mechanism of the greenhouse effect, of course, it's named after what happens in a greenhouse. If you've ever been in a greenhouse is usually made out of glass or plastic, and sunlight can enter the greenhouse, but infrared radiation cannot pass through the glass or the plastic, thus keeping the heat inside. So is there a correlation between global temperature, the increase in global temperature, and the production of carbon dioxide by fossil fuels? This, of course, is the big question that is controversial. That is, how much of the production of carbon dioxide and leading to an increase in global temperature is due to the burning of fossil fuels. Well, here's some data so that you can use your judgment. The left shows the total consumption in terms of metric tons of fossil fuels since about 1800 on. You see that at some point in time, after about 1900, Industrial Revolution, there has been a significant increase in the consumption of these fossil fuels. That's the black line, the top line. And if you look to the right, you see the temperature increases over this similar period of time. As you can see, they both are increasing at similar rates. So this is a correlation. Questions, of course, are does one cause the other, or do they just happen to be coincidence? Of course, because we know the mechanism of the greenhouse effect and that carbon dioxide does absorb infrared radiation, there is a scientific basis for there potentially to be this cause and effect between carbon dioxide levels and the increase in global temperature. Okay, we're going to pause at this point, take a little quiz, and then continue on in our discussion of the greenhouse effect, and we'll move into a discussion of other possible drivers of climate change. See you shortly.